According to the National Electrical Code, specifically Section 500.8c, a dust ignition-proof enclosure is required for Class 2 Division 2 Group G areas. A NEMA 4 enclosure, by itself, does not meet the requirements for a dust ignition-proof enclosure as defined by the NEC. It is important to understand the specific requirements for enclosures in hazardous locations to ensure safety and compliance with regulations. A NEMA 4 enclosure is designed to provide protection against ingress of water and solid objects, but is not specifically designed or tested to prevent the ignition of combustible dust. To make a NEMA 4 enclosure suitable for use in a Class 2 Division 2 Group G area, you would need to implement a purge system. This purge system must maintain a continuous positive pressure of clean air within the enclosure. The purpose of the continuous positive pressure is to prevent the accumulation of dust inside the enclosure, which could potentially lead to ignition. The clean air supply must be filtered and free from any contaminants that could pose a risk of ignition. The purge system should be designed to ensure that the enclosure remains positively pressurized at all times, even during periods of maintenance or power outage. The flow rate of the clean air should be sufficient to effectively remove any dust that may have entered the enclosure. The purge system should also be equipped with alarms and monitoring devices to alert personnel of any malfunctions or deviations from the required pressure and flow rate. NEMA 9 enclosures are specifically designed to be dust-tight and are suitable for use in Class 2 Division 2 Group G areas without the need for a purge system. However, since you have stated that you do not want to use a NEMA 9 enclosure, this option is not available. Therefore, using a NEMA 4 enclosure with a properly designed and installed purge system is your only remaining option to meet the requirements of the National Electrical Code for Class 2 Division 2 Group G areas. When selecting a NEMA 4 enclosure for use with a purge system, it is important to consider the size and shape of the equipment that will be housed inside the enclosure. The enclosure should be large enough to provide adequate clearance for the equipment and to allow for proper airflow around the equipment. The enclosure should also be constructed of a material that is compatible with the environment in which it will be installed. The enclosure should be resistant to corrosion and other forms of degradation. The purge system should be designed to be easily accessible for maintenance and inspection. The system should be equipped with readily available replacement parts. The purge system should also be designed to minimize the risk of dust entering the enclosure during maintenance or inspection. The purge system should be installed in accordance with the manufacturer's instructions and all applicable codes and standards. The purge system should be regularly inspected and maintained to ensure that it is functioning properly. The inspection should include checking the air filters, the pressure gauges, and the flow rate of the clean air. Inspection should also include checking for any leaks in the enclosure or the purge system. Any leaks should be repaired immediately. The purge system should be equipped with a backup power supply to ensure that it continues to operate in the event of a power outage. The backup power supply should be sized to provide sufficient power to operate the purge system for a reasonable period of time. The purge system should be designed to be energy efficient. The system should be equipped with controls to minimize the amount of clean air that is used. The system should also be designed to recover any waste heat. The purge system should be designed to be environmentally friendly. The system should be equipped with filters to remove any pollutants from the exhaust air. The system should also be designed to minimize the amount of noise that is generated. It is imperative to consult with a qualified electrical engineer or other qualified professional to ensure that the purge system is properly designed and installed. The engineer or professional can assist with selecting the appropriate equipment and designing the system to meet the specific requirements of the application. The engineer or professional can also provide guidance on the proper installation, operation, and maintenance of the purge system. Remember that working in hazardous locations requires specialized knowledge and training. It is important to follow all safety procedures and to wear appropriate personal protective equipment. It is also important to be aware of potential hazards that are present in the location and to take steps to mitigate those hazards. Always consult the relevant codes and standards for specific requirements and guidance. The National Electrical Code is a comprehensive set of rules and regulations that are designed to ensure the safe installation and operation of electrical equipment. It is important to be familiar with the relevant sections of the NEC when working in hazardous locations. In summary, for a Class 2 Division 2 Group G area, a NEMA 4 enclosure alone is insufficient. A purge system providing continuous positive pressure is necessary to meet the dust ignition proof requirement. While NEMA 9 enclosures are suitable, they are not your preferred option, leaving the NEMA 4 enclosure with a purge system as the viable solution. Ensure proper design, installation, and maintenance of the purge system to guarantee safety and compliance.